Hey guys, Mr. Height here. This is part 3 of the AP Environmental Science Chapter 8 lecture. Okay, so we left off talking about developing hotspots. Keep in mind that for something to be considered a hotspot, we're going to look for something that's rich in highly endangered endemic species. So species that are really close to extinction. Remember, endemic means it's only found in that one place in the whole on the whole planet. So we want to look for those, like where are those found, and intersect that with ecosystems that are threatened by human activities. Remember, a few slides ago we said we want to try to fix ecosystems first that are messed up, but not beyond the point of no return. So to be considered a hotspot, it has to have lost at least 70% of its original habitat and contain at least 1,500 endemic species of vascular plants. So each hotspot has at least 1,500 species that are found nowhere else, strictly of vascular plants. We focus on vascular plants because they're called vascular because they have a system to transport things like water, mineral salts, and sugars. So that's like they have veins. That's why they're called vascular. So some examples of those would be like ferns or pine trees, things along those lines. Some flowering plants. So in total, our hotspots cover about 2% of the Earth's surface, but they contain approximately half of the world's flowering plants and about 42% of all terrestrial vertebrates. So that's mammals, birds, anything with a backbone that lives on land. Only of that 2%, only about 5% of that is truly protected through government policies, governmental funding, and things along those lines. This map shows where all those hotspots are. If you notice, the middle of the U.S. doesn't have a lot of hotspots. Canada doesn't have a lot. Russia doesn't have a lot. Russia doesn't have any. Remember our qualifications. 1,500 endemic plant species. So things that are tropical, makes sense that they would have a lot more of those endemic species. So in terms of protecting ecosystem services, I kind of skipped over that when I was talking about the hotspots. So think about, we're determining where we can get the most bang for our buck. Where can we save the most species? Well, if we view that through the lens of ecosystem services, where can we get the most bang for our buck in ecosystem services? Where can we get the most carbon taken out of the atmosphere? Well, protect forests, protect coral reefs. Okay, so let's start there. Now let's branch out from there and see which forests and which coral reefs specifically contribute the most to ecosystem services. So in 2005, the UN Millennium Ecosystem Assessment outlined how to protect those ecosystem services, basically by creating reserves around biodiversity hotspots. Essentially, it becomes a whole world project. We all have to work together to come up with ways that we can protect ecosystem services and still harvest sustainably. That's what this whole chapter is about. How do we get to sustainability? So, part of that, we talk about protecting ecosystems. Now let's look at the ones that are already messed up. How can we fix them? Well, let's use reconciliation biology. Let's let biology do what it does. Let's let it go through secondary succession. Can we let it alone and let it do what it does? If not, what do we need to do? Do we need to replace the ecosystem? Do we need to create an artificial ecosystem? Do we need to recreate a wetlands? What do we need to do to allow primary and secondary succession, really in this case it would be secondary succession, to take hold? And how can nature fix itself? So this slide talks about some strategies. This isn't going to shock you. What's messing it up? Figure out what's messing it up. Stop that somehow. Reintroduce keystone species. So put the most important species back in so you can restore ecology. And then protect them from further infringement. Don't let the mining company back in. Don't let Clive Bundy graze his cattle. Don't let invasive species back in. So find the problem, stop the problem, fix the ecology, protect the ecosystem. Pretty straightforward. I've used this term several times, reconciliation ecology. Essentially, it's how can we align ourselves with nature? Well, we can conserve species diversity. That makes sense. Central Park is essentially a nature preserve in the middle of a metropolis. Use sustainable forms of ecotourism to protect local wildlife and ecosystems. I know when I've been snorkeling in the Bahamas and places like that, they number one, they don't anchor to the reef, which protects the reef. Number two, they don't allow you to wear sunscreen, and they supplement with a zinc oxide, like they give you safe sunscreen to use. So that's kind of an example of sustainable ecotourism. And then teach local populations to protect your stuff. So start from the ground up. What do we have that we can protect? Okay, we can protect our watershed. We can protect, maybe we can protect our grasslands. Maybe we can protect our forests here in Montgomery County. We'll take care of ours. Boone County can take care of theirs. Putnam County can take care of theirs. And then together we'll have really made a difference. Moving on to aquatic biodiversity. I'm going to go through this section as quickly as possible. A lot of parallels exist. What's best on land is going to be what's best in the water as well. We're going to protect we're going to establish sanctuaries. Instead of calling them a wilderness area or calling it a wildlife preserve, it still is wildlife preserve, but it's in water instead of on land. We need to reduce pollution, but this time we're talking about air and water pollution. Prevent overfishing for sure. So, of course, we're good at messing stuff up. If you haven't looked at mangroves at all this year, this is a really good time to look at mangroves. But we have destroyed and degraded coastal wetlands, reefs, mangroves, and the ocean floor. A lot of those issues, a lot of those ecosystems being broken down are the root cause of a lot of the struggles with the hurricanes we've been having. Our wetlands are degraded. Wetlands would catch a lot of that water, would filter a lot of that water as it returned to the ocean or returned to the watershed, and those aren't working currently. You see the list of threats to freshwater and marine systems. Again, probably nothing life-altering there. Of course, we know that trawling is really, really bad, trawling fishing, so make sure you understand that and why it's so bad. I think we all do. Overfishing is the biggest problem. Maybe not. It's a huge problem in the ocean. Industrial fishing fleets basically use GPS and fish finders and things like that. They're really good at fishing. We're really good at harvesting things. We're especially good at catching really big things. So if you look here, this picture is way too small for you to read. It's on page 261 in your book. Talks about all the different strategies for fishing. Start at the top left. It's a fish farming in a cage. So you've got a small area. Then you've got trawler fishing where you're pulling a net. That looks a little bit like Nemo. You got lines with hooks. I would call that a trout line if I was fishing on a creek. There's deep sea aquaculture cages that are really cool. It's basically a cage that's really deep in the ocean that's connected to a bobber that you can reel it up and you can catch all those fish. But it's still it's a farm, basically. And then drift net fishing, you're going to tow a net and catch whatever's around it. And then purse seine fishing, you can see there, it's kind of like you cast a net, whatever. So, the idea of a fish print is new to a lot of people in environmental science. It's an ecological footprint, but for fish. So how is your fish consumption impacting the planet? Area of the ocean needed to sustain the fish consumption of an average person. So, or if you're looking at the fish print of the United States or the world, how much ground do we need to support that? Some more vocab there. Fishery is a concentration of aquatic species. Sorry about the typo there. Suitable for commercial harvest. That might be just a place where fish school, and it might be like a fish farm like you saw in the last slide. Overfishing has led to some of the world's major fisheries collapsing. Most of our big fish are gone. So we're left to eat the smaller fish, and now we have to eat more of the smaller fish, which only exacerbates our problem. Next threat's ocean acidification. I think we're in good shape here. But reefs in particular are vulnerable to ocean acidification. We've got the warmest and most acidic ocean waters in the past 400,000 years. Warmest, most acidic ocean water. Crazy. So, since the Earth's oceans have absorbed a lot of that excess carbon dioxide, that's of course going to change the chemistry of the water. It's going to make it more acidic. There's less availability of bicarbonate ions. We're going to talk through vinegar baking soda reaction here next week or this week, and I think that'll make a lot of sense. Dead zones are what they sound like. They're areas where nothing can survive. Typically, a dead zone follows an algal bloom. So there's a ton of nutrients that flow down. So picture Gulf of Mexico, a bunch of farmers dump fertilizer up the Mississippi River, maybe in Ohio, maybe in one of the other tributaries. All that fertilizer runs to the Gulf of Mexico. In the Gulf, there are algae that can, number one, photosynthesize, but can, number two, they can take in all those nutrients. So they're gonna go crazy. And as they take in those fertilizers, they're gonna grow like crazy, and they're gonna consume a ton of oxygen, and then they're gonna die. Bacteria is then gonna come in and use the oxygen to break down, to decompose the algae that's really gonna sap all the oxygen out of the ecosystem, and there's gonna be no life in that area for a pretty long time. So, can we protect and sustain marine biodiversity? Yeah, but it's tough because our fish prints are expanding. Ocean damage, like I said, and I still can't remember the movie, but it's hard to see how you mess up the ocean. It's so big that people think, there's no way I can mess it up. There's no way we're ever going to run out of that. Look how big it is. And here's a big problem. It's the tragedy of the commons. Most of the world's ocean, it doesn't belong to anybody. It's subject to the law of the sea. So our U.S. laws don't mean anything. Mexico laws don't mean anything. So as a globe, we have to decide on what's important and what we're going to protect. So we can protect marine ecosystems by establishing these marine protected areas that offer small protection, but it's not nothing. 41% of U.S. waters are protected in some manner. Can't dump cyanide in them. Not all waters, but some of them. 40% of them. Marine reserves are going to be like a wilderness area, full protection from human disturbance, and that does allow quick recovery. But again, it's expensive and they're few and far between. So how can we use the ecosystem approach in aquatics ecosystems? Number one, we got to finish figuring out where these biodiversity hotspots are in the water. Number two, we need to expand and fund our marine reserves. Marine reserves, personally, I have a hard time prioritizing what's more important, coral reefs or tropical forests. They do a lot of the same ecosystem services. Coral reefs have a few more ecosystem services than do forests, but they're both really important. So can we do both? Can we protect marine reserves and can we protect terrestrial reserves? Can we do global ecological restoration projects? Is there a way to increase participation across the planet? And then again, reduce poverty in areas near protected lands and waters, particularly near the equator and tropical areas where that poverty is leading to deforestation and things along those lines. So that's the Chapter 8 lecture. Hope you enjoyed it.